Hello there. Welcome to this video. In this video, we're going to take a look at using the Ciw Python package to run simulations, pause the simulation, and then restart the simulation where we left off. Some of the reasons why we might want to do something like this may be that we're only interested in simulating for a certain amount of time, checking if you're in a particular trajectory of what is the property of this system for the sake of interest. You might also do it for reasons like that you need to inject some kind of disturbance into the system, and so you're going to patch in some changes to the state of the system after some amount of time and then continue the simulation. That might be another reason. So with that, let's just jump into the how-to here. So like anything where we're simulating with Ciw, we need to import the Ciw Python package, and we need to define a network, and we'll continue using this create network function here. So we got arrival distributions, which here I've just set it to be an exponential with a rate of 1. I'm not particularly concerned for this video about designing the queuing system itself. We'll just follow along with the official documentation of using a rate of 1 for the arrival distributions and a service of 2 for the service time distributions. Now, just as a bit of context to remember about this rate parameter for exponentials is that the average arrival times and the average service times will actually be 1 over the rate. So the arrival time distributions will on average be a unit of 1 time step, and for service time distributions that it'll actually be 1 over. So we're actually going to have faster completions of service than we will have arrivals. That's kind of built into what we're thinking about with the rates, but in terms of the average amount of time, it's the reciprocal. So let's also put in the number of servers here, and we'll just put that for now as 1. So we've defined a network, but we need to go a bit further in terms of setting up the system. We'll set a seed number, we'll call it seed of 0. That just controls the pseudo-random number generation in the simulation. Then we'll go Ciw.simulation, and we will pass in our network. So this is an instance of a simulation, and we can run the simulation by going simulate, and there's various options here. We're doing until maximum time, although as far as I understand, it should, what I'm going to show you of being able to start and then continue on, should also apply to those other methods. So simulate until maximum time, and here we're going to go simulate until 5 units of time have passed. Now, with these kind of simulations, the simulations don't inherently have some notion of which time scale we're talking about. This 5 could be 5 minutes, 5 days, 5 hours, 5 billion years, whatever you want. Okay, and for that matter, let's also import pandas because we'll want to pull out some results just to show what the documentation wants us to show here. And we're also going to do we're going to select some columns for the sake of what we want to look at here. So let's call this selected columns, and we're going to grab some information from the records, but we're just going to put this into a tidy lists indexing. So, or sorry, not list. What is it? It's not even dictionary. It's like named tuple, I think is what the type actually is. Waiting times. So we're just going to grab this data from the simulations. The selected columns, we're going to grab the ID numbers, and that will be important just to show that we've really continued on when we're looking at the record numbers, and just to see some numbers that should line up that are not just purely identifiers, that will get some arrival time and waiting times as well. So let's grab the records. The records are going to be captured by going sim, and then we can get all the records this way. Okay. And with that, we can then, well, you know what? I mean, what do I want to do here? I feel like it's fine to just go straight to converting this into a data frame, actually. That should be fine. I do need to import it as PD if I want to use that PD abbreviation. Then I should be able to go records and pass in selected columns. And just to make sure we're actually going to look at something when we run this, let's print it. So then if I go Python, how to pause. I should get an error that ID numbers is not in the index, and that's because, typo, it's just number, not numbers. So, you know, you always have to look carefully at what things are expected from a tool. Right, so let's look at some of these numbers just for a little bit of seeing some numbers that we can then expect when we rerun this for a longer amount of time. Is like, let's say the bottom two numbers there are 3.22 and 0.46. So we should expect to see that when we've simulated until time 5 and then we continue on, we should see those numbers. What is that for ID number 4? So let's do that. Let's set up the simulation. So we're actually going to go further of going same simulation object. We're reusing it, and let's simulate again until maximum time. And we need to set a time that is larger than 5, which is the amount of time we simulated before. If we don't, then it's just going to say that there's no more simulation to be done. So we'll follow the documentation of setting that to 9. And we can reuse some of that code right there. We're just going to grab that same information, grab the records. And so let's take a look just to validate here that we're really continuing on and not doing just a different simulation altogether. So for record number 4 in this top table, that we've got that 3.22 again and that 0.4686, and we should be able to look down here to record 4, and there it is, 3.2246, and actually all of these other ones above match, which is what we should expect. And yet it continues on to record 5 and 6 and 7 and 8 and 9. So this is how you can run a simulation for a certain amount of time to pause, maybe grab whatever data you want out of it, and then continue on, or to manipulate the state of the simulation at that time and then continue on. So hopefully you find that helpful, and I will see you in the next video. Take care.